2.5a, implicit differentiation. All right, cool. So if you have explicit form, where x's and y's are together, so I have x times y equals 1. Well, could we actually solve for y on that? Yes, I sure could. So if I solve for y, I divide by x, so I get y equals 1 over x, right? And then I take a derivative with respect to x. So the derivative of y with respect to x is equal to negative 1 over x squared, right? We know how to do that by the power rule. That one was actually on your last quiz, all right? But what happens when I have something like this? I get x squared minus 2y cubed plus 4y equals 2. Solve for y. Can you solve for y? No. So does that mean we can't do it? No. We have other ways to tamper, and that's when we're going to use implicit differentiation. So we need some readers. Abby's going to read for us.
Guidelines for implicit differentiation. Differentiate both sides of the equation with respect to x. Collect all terms involving dy dx on the left side of the equation and move all other terms to the right side of the equation.
All right, so I don't care if you put it to the left or to the right side of the equation. That doesn't matter. Put them wherever you feel like they need to be. However, you need to group all your dy dx terms. All right, keep going.
Factor dy dx out of the left side of the equation and then solve for dy dx.
And then solve. So those are our guidelines. So let's put it into practice. Here we go. So, you know what? So if I have to take a derivative of x cubed with respect to x, I'm taking a derivative with respect to x of x cubed. Well, what's the derivative of x cubed? It's right here. What's the derivative of x cubed? 3x squared. Right? My variables match up. I'm taking it with respect to x of x, so my variables match up. Now, what happens if I take a derivative with respect to x of y cubed? Well, it is disrespectful. True that. All right, but what's the derivative of y cubed? It would still be a power rule of 3y squared. However, my variables disagree. And so here, I now have a dy. I took a derivative of y with respect to x. A dy dx pops out because my variables don't match. And I want to show you on this first one. The derivative of x cubed is 3x squared, right? But what really happened was a dx over dx happened. Because I took a derivative of x with respect to x. Now, why don't we show that? What is dx over dx? It's 1. So do I actually have to show that? No. All right. Now, let's go back a little bit further. If I say it's y equals 3, or not y equals 3x squared, but y equals x cubed, right? How do I say I'm taking a derivative? What is my derivative of y? Dy dx, because I'm taking a derivative of y with respect to x, which would be equal to what? 3x squared. So truly, you've actually been doing implicit differentiation, you just didn't know it. All right? So let's do it again. So now I'm going to take a derivative of x plus 3y with respect to x. So, what's the derivative of x? 1. Plus, what's the derivative of 3y? 3 what? Dy dx. Because my variables don't match. I'm taking a derivative of y with respect to x, so a dy dx pops out. All right, let's look at part D. So now I have x times y squared, and I'm taking a derivative with respect to x again. What rule is happening here? The product rule. So let's use the product rule. The derivative of my first is 1 times y squared. Does a dy dx pop out there? No, because I took a derivative of what? X. All right, I took a derivative of x. And now, plus the derivative of my second. So what's the derivative of my second? 2y dy dx. And then times my first of x. And all I would do is simplify it up a little bit. So now I end up with y squared plus 2xy dy dx. All right. Usually x's come before y's because it's alphabetical. All right, pretty good? All right, it's not wrong if x comes after, but like, all right, cool. Here we go. Let's write this one out. I got y cubed plus y squared minus 5y minus x squared is equal to negative 4. And I want to find dy dx. Let's not forget what we're doing here. What does dy dx represent? The slope of a tangent line. That's what it represents. I'm taking a derivative. I am finding a slope of a tangent line. All right, so here we go. So what's the derivative of y cubed? 3y squared dy dx. Plus, what's the derivative of y squared? 2y dy dx. What's the derivative of negative 5y? Negative 5 dy dx. Then what's the derivative of negative x squared? Negative 2x. That's it. That's it. Because it's really a dx dx, right? But I don't need to write that. And then it's equal to 0. All right? I'm going to share a common mistake that students have all the time. They forget to take the derivative of the constant. All right? What's the derivative of a constant? 0. Make sure you do that. All right? All right, so now I need to get all my dy dx's together, and I need to get my not dy dx's over to the other side. So I personally would add 2x to the other side. You following me? All right, so I'm going to add him over. And so now, what can I do with all these dy dx's? I can factor it out. All right, so now I'm going to factor out a dy dx. And so what am I left with? 3y squared and then plus 2y minus 5. All right. And so let's solve for dy dx. So what are we going to do? We're just going to divide by that quantity. So now I have dy dx is equal to 2x over 3y squared plus 2y minus 5.
Can you factor out 3y squared plus 2y minus 5?
I don't care to. I don't know. Maybe. But it's good right there. All right. All right. So I want to talk about notation a little bit. Remember when we could take a derivative and then say x equals something? All right. Remember how we did that? Well, now, when I have a derivative like that, I can't say it just x equals something anymore. I would have to say dy dx at what? What do I need? I don't need just an x anymore. I need both an x and a y. So now I need the whole ordered pair, the whole point. And so this would now be like our x and our y. All right. So I want to go over some notations. We're going to practice it on the next problem though too. All right. All right. Cool. Let's move. Here we go. So we're going to find the slope of the tangent line. All right. We're actually going to find the whole tangent line as well. Of x squared plus 4y squared is equal to 4 at the point square root 2 comma negative 1 over square root 2. Does anybody know what graph that is? See how much we remember from pre-calc. What kind of shape does x squared plus 4y squared equal 4 give us? An ellipse. That's an ellipse, exactly. What I would tell you to do in pre-calc was divide everything by 4, so it'd be x squared over 4 plus y squared over 1 equals 1. All right? And so that is actually an ellipse. So we're going to take a derivative of an ellipse. So here we go. Well, what's the derivative of x squared? 2x. Plus, what's the derivative of 4y squared? 8y dy dx. Very good. Is equal to 4. No, it's equal to what? 0. Very good. So now I'm going to solve for dy dx. So how do I do it? Subtract 2x and then divide by 8y. Can we do 2 steps at once? We could? All right. So there's my dy dx. Now, I'm actually going to find the slope at that point. If I were not to find the slope, I would leave it just like that. However, because I'm going to use it, I personally would simplify this up. So what does this simplify to? Negative x over 4y. All right, negative x over 4y. So now I'm going to take a derivative. So dy dx at the point square root 2 comma negative 1 over square root 2. So now I'm going to substitute in. So now I end up with, what's my x? So now I have negative square root 2 over 4 times, what's my y? Negative 1 over square root 2. And so now we got to do a little bit of math. All right, what happens to my negatives? They cancel. So now I have like a 4 over square root 2 on my denominator, right? But really that's multiplying by what? The reciprocal. So I'm really multiplying by square root 2 over 4. So what does that become? 2 over 4, which is 1/2. So my slope of my tangent line at that ordered pair is 1/2. Now, I personally want to make an equation of my tangent line, so let's do it. So we get y equals what? 1/2 times x minus square root 2, and then what? Minus 1 over square root 2. All right? And that is our equation of that tangent line right there. All right, see the ellipse now? All right. So this slope right here is 1/2. What if I did square root 2 comma 1 over square root 2? Because that'd be the point right there. What would be my slope? What do we think? It'd be negative 1/2. All right. And so, but this equation right here will give me my slope of anything on that ellipse. You find that kind of nifty? All right, it's actually pretty cool in my opinion. All right, write those out.